Greetings to you all. Welcome to Grade A Tutor. Today we are going to look at application of differentiation. And so application of differentiation, here we are going to look at the practicality. So in our previous lesson, we looked at how to calculate um, implicit functions, how to differentiate product functions, quotient functions, and all that. But this time around, we are going to look at how it is to the benefit of organization or companies. Do you get it? And so for application of differentiation, we are going to apply it in our daily lives or the work of any company or organization. And so we have certain terms. So we have total cost. Normally it is represented C of X, right? So when you see C of X, have it in mind, it is what? Total cost. Then we have um, total, so let me go for marginal first. So marginal cost, that is M of X, okay? Then we have total revenue. We have total revenue to be R of X, okay? Then we have marginal revenue. We have marginal revenue, that is M prime of X, right? This M prime of X, and the marginal revenue is MR is equal to MR, and this is MC, right? And this is MR of X, okay? Then we have profits, which is also, or should I say total profits, which is also represented by P of X, okay? Yes, then marginal profits, normally you see MP of X. So these are the terms that we are going to look at, okay? So when you hear them, try to understand or memorize it from here, okay? So in most of the questions under differentiation, you would be given what? Total cost of production of that particular organization, okay? So whenever you are given what? Total cost, you see, yes, total cost first, okay? So always we differentiate total cost to get what? Marginal cost. Do you get it? And most of the times to revenue will be given, you have to differentiate the revenue to get the marginal what? Revenue. Sometimes you calculate the profit yourself, then you find for what? Marginal profit. So the total cost, what does it mean? You know the total cost of production of any organization, that is the fixed cost plus the variable cost. You get any cost incurred by the organization at the end of any period is what? The total cost. I hope you get that. And so the marginal cost, they want to know if they increase, let's say, production by one marker. If they increase one production of a marker, what cost are they incurring? Or let's say, what is the gap between the original cost and the new cost? Do you get it? So the same thing applies to everything that we have here. So that is basically what we are going to look at. And so whenever you see total cost like this, you have to differentiate total cost to get what? Marginal cost. We don't differentiate marginal cost to get total cost. You differentiate total cost to get marginal cost. I hope you get that. Yes. And so when you get marginal cost, it is just like getting dy dx. Do you get it? And so when you get dy dx and you want to get your point, what do? You equate it to 0. So it's the same thing. If you want to calculate how an organization maximize profits or how organization maximizes profits, it means you have to equate your marginal cost. Do you get? Sorry, if you are calculating for the cost, you have to equate what? The marginal cost to 0, because the marginal cost here serves as what? Dy dx, because that's the first differential from the total cost. So if you equate the marginal cost to 0, it means you are going to get the point for x. Do you get it? So after getting the point for x, you then proceed by differentiating it again to the second differential, just like what we did. Then you test for the value of x. Do you get it? If you test for the value of x, and any figure that you get would let you know whether the company or the organization is maximizing or minimizing. Do you understand? Yes. We will run through some small and very simple question for you to understand it more under differentiation, application of differentiation. But also note to it that I said when you differentiate total cost, you get marginal cost. And for profit, you always know profit is equal to what? Your revenue minus what? Cost, right? Then your marginal profit here would be equal to your marginal revenue minus marginal cost. When you hear marginal, the marginal has to come. Do you get it? Yes. So now let's take a question, and we look at how to solve application of differentiation. So the first question, because of time, I would be interested in giving you the functions in other than reading the questions and all that, because of one or two reasons. Okay, so let's start. The first question says we are selling what? Transistors. So x transistors. So we don't know the quantity that we are selling. Do you get it? So we say our quantity. We say the quantity is what? X. The quantity of the transistor is what? X. Okay. Yes. And so look through the question. You see that the question also provided us with what? Cost function. Cost function. So cost function is Cx, C of x is equal to what? 5,000 plus 2x. So we have 5,000 plus 2x. That is what the cost what function, the total cost function. Then we were given the price function. That is 10 minus x over 1,000. Okay. Yes, there's the price what function. Okay. So now we have to what? Calculate the maximum revenue. We have to calculate the maximum profit, the production level that will realize the maximum profit, and the price that the company should charge for each what radio. Okay. And so it's very simple. Let's look at how to solve it. Okay. So how do we calculate for marginal cost? We know that is when we differentiate our total cost. So now let's look at how to solve it. Okay, now we have to, first of all, we have to calculate for what? How to maximize, or yes, the maximum revenue. And so we say every revenue is equal to the price times what? Quantity. The price times what? The quantity. Right? So if I have 10 markets and one sells at 2 Ghana cedis, the price times the quantity, 2 times 10 is giving me what? 20 Ghana cedis, and that is my what? Revenue. Okay. So for us to calculate for the maximum revenue, it means we have to get our revenue function, but we were not given any revenue function. But we have the price function here, we have the quantity function here, right? So let's multiply them. So we say our revenue function would be price, that is 10 minus x over 1,000 multiplying what? X. So this is our revenue. Okay. So now if we expand, we have 10x minus x squared over 1,000. So this is now our revenue function. This is our revenue function. Okay. Yes. And they are saying we should calculate, or we should find how to maximize what? The revenue. So if you want to maximize the revenue, listen to the word maximize. So you are going to find the maximum value. And if you want to calculate for the maximum value, what do? You have to differentiate it. And so when you differentiate total revenue on this revenue, you get what? Marginal revenue. marginal revenue. Okay, so you have marginal revenue. Let's differentiate it. This one would give us what? 10. Okay, minus x squared will give us 2x over what? This 1000. Okay, then we move on to okay, at this point we can calculate for the value of x. Okay, because assuming this is what? Dy dx, and you want to calculate for the value of x, or the stationary point, right? So you equate it to 0. So you always equate the marginal towards 0 in order to obtain the value of x. So you have 10 minus 2x over 1000 equal to x, sorry, equal to 0. So now we are going to make x the subject. So let's multiply through by 1000. We multiply this by 1000, this by 1000. Okay, so let's use this piece. Okay, so we multiply this one by 1000. We have 10,000 minus, we multiply this by 1000. You see that the 1000 will cancel this 1000. So we have minus 2x, okay, equal to this x, equal to what? 0. So now we group like terms and we say 10,000 is equal to 2x. Divide both sides by 2. And you can see your x is equal to what? 5,000. So now x is equal to 5,000. Okay, so you see our x is equal to 5,000 now. So now we are going to check whether it is what? Maximum or minimum. Okay, so we have to find the second differential, right? So the second differential, this one is mr, right? So we can say the r square, you can say the r square over the square x over the square x is equal to, don't forget, this is revenue, and we differentiated this to get what? The r over the x. Okay, and the second differential is what? The r square over the x squared. So don't forget. So we are going to differentiate what? This function again to test whether it is maximum or minimum. Okay, so if you differentiate this, you get 0. If you differentiate this, you get what? This is what? Negative. If you differentiate this, you get negative 2, right? So you have negative 2. This you get negative. This is 0. Negative 2 over what? 1000. So these two will go into the 1500, right? So you have negative 1 over 500. So you see the answer for the second differential is negative. So it means the revenue is what? Maximized. Okay, the revenue is maximized. Then the question said we should calculate for where is it? We should calculate for, yes, the maximum revenue. And so now, since we have the value for x, where is the revenue function? This is the revenue function, right? So it means when we put in the value of x into this revenue function, we get our revenue, the value for the revenue. Okay, yes, or the particular amount. So now we are going to substitute this 5,000 into this one. So all that you have to do is just get the value of x correct. If you get it correct, now you have the price function. So if they ask you to calculate for price, you just insert the x. You have the cost function. If they ask you to calculate for cost, you insert the same x. You have the revenue function. If they ask you to calculate for revenue, you insert the x. So the best way, or the best thing that will help you in the calculation, is to get what? The x what? Correct. Okay, so now the revenue is equal to 10x. So we say 10, then we multiply it by 5,000, minus, we say 5,000 squared over 1000. So what are we getting for our revenue? So our revenue is 25,000 cedis. Our revenue is 25,000 cedis. Okay, so this is the maximum what revenue from the question. This is the maximum what revenue, and they said we should calculate for what profit. And you know profit is what revenue minus what cost, right? You know profit is revenue minus cost. It's because I need space. I'm going to clean this side, then I use it for the next calculation. They said we should calculate for the profit, or is it maximum profit? Okay, so maximum profit, we don't have the profit function, so we have to calculate for the profit. We have to derive the profit function. Then after getting the profit function, we use the profit function the same way to get what x. Okay, so we are going to follow the same way to get what x, and that x we get, we put it in the profit function. That is all. You see, for the revenues on, we had x equal to 5,000. Then we substituted it into the revenue function to get our 25,000. The same thing for profit. You get the profit function. You follow the same steps to get the x value. Then you insert the x value into the function to get the maximum profit. Okay. So you know profit is equal to revenue minus cost, right? Now, you will see we had the revenue function, right? I've cleaned it. What was the revenue function? We had the revenue function to be 10x minus x squared over, is it 1,000, right? Um, it was 2x. Oh, okay, that is it. So this is the revenue function. So this function minus the cost function, this one, 5,000 plus 2x. So these two functions is what will give you the profit function. Okay, it's what will give you the profit function. So you have 10x here, right? So let's expand the bracket first. Other than that, we'll get the answer wrong. So over 1,000 minus this negative is affecting this, so 5,000 minus 2x. Okay, so you see, if you don't bring the bracket, you have the plus here, and at the end you are going to get it wrong. So 10x minus 2x is what? 8x. Okay, minus, we have x squared over 1,000 minus 5,000. So this is our profit function, right? So this is our profit function. This is our profit function. And so for this profit function, what do? We differentiate it, then we equate it to 0 to get the value of x. Then we put the x in this function to get our value, right? As simple as that. Okay, so now let's differentiate this. When we differentiate the profit function, what are we getting? So okay, so when you differentiate it, you get marginal profit, right? Yeah, so marginal profits. Marginal profits. So if you differentiate 8x, you get 8 minus, this one will give you 2x over 1,000. Then there is a constant term, so 0. Okay, yes. So you equate everything here to 0, just like the first step. 2x over 1,000 equal to what? 0. And so this one, then you multiply this one by 1,000, this one by 1,000, so that you get it in linear form. Okay, so let me clean this one, use the space for that calculation. And so we are going to multiply here this one by 1,000. So we say 1,000 times 8 minus 2x over 1,000 times 1,000. Okay, equal to 0. So you see that 1,000 times 8 will give you what? 8,000. Right? Then this 1,000 will cancel out this 1,000. So you have negative 2x. Okay, equal to 0. And so in this case, you can say you have 8,000 equal to 2x. You divide both sides by 2. So you have x is equal to what? 4,000. your x is equal to 4,000. Okay, so you see, for the revenue function, the x was 5,000, but this one, the x is what? 4,000. So if the x is 4,000, you just come and put the 4,000 here. But if it is theory, you also have to differentiate this function again. Where is the marginal? Yes, you have to differentiate this in order to prove that the how do we call it, the profit is maximum or minimum. Okay, so we say marginal profit, right? So the p square over the s, the square p, let's say the square p over the s square is equal to um if you differentiate this, 0. If you differentiate this, what do you get? You get 2. So you have negative 2 on 1,000, and at the end you are getting the same 1 over 500. And so this is what? Maximum. So it means the profit that we get, we are going to get is what? Maximum profit. Okay, so we have our x here. We are going to put the x in the profit function to get the profits that they are asking for. So we say profit is equal to 8 into bracket 4,000 minus 4,000 squared over 1,000 minus 5,000. Okay, so we are putting x in the profit function. Don't put it in the marginal profit function. We are finding what? The profit. If it were to be marginal profit, then we would have used what? This function. But because it is what? Maximum profit, so we are interested in this. Okay, yeah, so when you substitute the 4,000, you get 11,000 Ghana cedis. 11,000 Ghana cedis. Do you get it? So the answer for the maximum profit is what? 11,000 Ghana cedis. And the question also said the production level that will realize the maximum what? Profit. So what is the production level? How many products should we produce before we get to that amount? Okay, don't forget we said x is what? The quantity. So x talks about the number of production. Do you get it? And so for profit function, the x was what? 4,000. So the production level, we must produce what? 4,000 quantity of that particular transistors before we make a profit of what? 11,000. Do you get it? And so that is the third one. Then the fourth one says the price that the company should charge for each what? Radio. So the price that they should charge for each radio before they attain that profit is, you just substitute this 4,000 into the price function. The amount or the value that you get is the answer. So for the price on, it becomes P equals 10 minus, what is the profit? The profit that we made was, no. Oh yeah, the x is what? 4,000, right? So we have 4,000 over 1,000. Okay, so if you solve for this, you see that you have P equals what? 6. So P equals 6 Ghana cedis. Okay, so it means those 4,000 quantity of goods, each sells at what? 6 Ghana cedis. You have to sell each at 6 Ghana cedis before you make a profit of what? 11,000 Ghana cedis. That is the interpretation. Okay, yeah, so this is application of what? Differentiation. This is one question. I'll give you one to try and you put it at the comment section. I'll come there and verify it for you. So this is one question. Okay, so now let's solve the second question, and we draw the curtain for differentiation. So this is the last question, and I'll give you one to try, then you provide the answer at the comment section. Okay, so from the question, these are the parameters. The quantity is x, the cost is 90,000 plus what? 30x, and the price function is 300 minus what? X over 300. So from the previous example, we are going to apply the same procedures. So I'm just going to solve the maximum revenue and the maximum I'm going to solve the maximum revenue, and I will leave the maximum profit and the level of production and the price for you to also solve using the previous example. So let's look at how to solve for the maximum revenue. Okay, so we know already that our revenue is always equal to our price times what? The quantity that we are producing. Okay, so there's our revenue, and we have the price, we have the quantity. So let's find the revenue function just like we did. So the price is what? 300 minus x over 300 multiplied by the quantity x multiplied by x. Okay, so let's expand the brackets. We have the revenue function to be 300x minus x squared over 300. So this is the revenue function. Okay, yes, and because they said we should calculate for the maximum revenue, we have to differentiate it to get x. Then we differentiate it again to know whether it is maximum or minimum. Do you get it? Most of the times, if it is MCQ, it is not necessary for you to find the second differential, because already the question is saying maximum what? Revenue. Do you get it? So after getting your x, you insert the x in the revenue function to get your revenue. But if it is theory, then you would have to solve it to the second differential before you substitute the x into the revenue function. Do you get that? So now let's proceed. First, we differentiate it. So let's differentiate the total revenue. Then we have marginal what? Revenue. We have marginal revenue. And if you differentiate this, that is 300 minus 2x, you know it, over 300. So this is the marginal revenue. And if you want to get the value of x, when you get the marginal revenue, you equate it to what? 0. So you have 300 minus 2x over 300 equal to what? 0. So now we are going to multiply through by 300. If you multiply 300 by this one, that will be what? So you have 300 multiplied by 300 minus 300 multiplied by 2x over 300 equal to 300 times 0 is automatically 0. Okay, so 3 times 3 is what? 9. Then you add your 4 zeros. Okay, so we have 9, then 4 zeros. Okay, then minus this one will cancel out this, minus 2x equal to 0. So we can say we have 90,000 equal to 2x. We divide both sides by 2 by 2. So therefore our x is equal to what? This and this 45,000. Okay, so our x is equal to 45,000. Okay, so since we have the x equals 45,000, if you insert this 45,000 into the profit, sorry, the revenue function, you are going to get your maximum revenue. But for examination sake, let's follow the procedure. So after getting the stationary point or the value of x, you have to differentiate it again. That is the square r over the x square. So you have to differentiate the marginal revenue function again. You differentiate this, giving you 0. You differentiate this to get what? Negative 2 over 300, right? So this is 1 and this is 150. So you have negative 1 over 150. So since it is negative, you see, it means the revenue is what? Maximum automatically. And even the question said that. So there is no need for you to even do this. But for examination sake, if it is theory, you have to bring it for you to get some tick. So now let's find for the maximum revenue. We are going to substitute this x into the revenue function. Right, so we say our revenue is equal to 300 times what? The 45,000. So we say 300 times 45,000 minus 45,000 squared over 300 over 300. Yes. Okay. So when you solve it, you get the maximum. You get the maximum revenue to be 1,282,500. So 1,282,500. So this is what you are going to get for the revenue. Okay, so this is what you are going to get for the revenue. So do same for the profit. So profit, revenue minus what? Cost function to get your profit function. After getting your profit function, you differentiate the profit function and you equate it to what? Zero. When you equate it to zero, you get what? The value of x. Then after getting the value of x, insert it in the profit function, and that is all. That is the maximum profit. Okay. So for the level of production, that is the value of x at which x makes it what? Profit. Do you get it? And if you are asked to calculate the price, you bring that x, not this x, the x that you are going to calculate for. You bring it here to calculate for what? The price. So this brings us to the end of what? Differentiation. And we'll meet again for our next topic. Once again, my name is Afari Ernest, and this is grade 8 tutor. Kindly subscribe to our YouTube channel and you like our video. If there is anything that you don't understand, you let us know at the comment section and our team will attend to you. Thank you very much.